All right, so here's a quick one for 6-4 the ready. In class, I want to make a clarification. When we talked about the task the other day, we had angle-angle similarity, we had side-side-side similarity, and I made a mistake. I made an oops. Okay. Some of you, I told some of your classes, I told you there was side-side-side similarity. I lied. It's actually angle, side, angle similarity. So make that clarification. As we move on, the other day you were supposed to look at these and determine whether or not they were similar and explain why. Those three explanations that I give, those are all shortcuts. So instead of in a long drawn out process in geometry, they try and narrow things down as much as they can. Those were shortcuts. If these two triangles are going to be similar, we're going to say they're going to be similar by angle-angle similarity, because you only see two angles in this one, two angles in that. Remember the example in class? If these two angles are congruent to these two angles, the third angle is automatically congruent, because all three angles, triangle sum theorem. Down here in B, it's either angles or sides. That's what we deal with. Well, I don't see any angles, so I can't use angle-angle or angle-side-angle similarity, but I can use side-side-side. But the problem is I have to compare corresponding sides. I don't care if you go big to small or small to big, make that comparison the same. And in class we went 8 over 22 is the same as 3 over 9, which is the same as 4 over 12. And if we start reducing all this, we get 4 over 11, we get 1 over 3, and we get 1 over 3. These are all not the same ratio, so these are not similar. Okay, it says determine if they are. And down here at the bottom, you see the angle again. Okay, this angle right here, which is kind of the peak, it's across from the longest side. Same thing here, across from the longest side. And it's the angle to the, let's call it to the right of that, So this would be angle-angle similarity. All right. Then we went ahead and we moved to this and said, find all the missing side lengths of the triangles. Well, we find that by comparing, right? We compare corresponding sides. So 8 over B is equal to, if I just start there with the short leg, A over 45, and that compares to 17 over C, which is the hypotenuse and the hypotenuse. All right, so the other day we looked at proportions. I could cover this one ratio up, and that's a proportion. I could cover this one up on the left, and these two are a proportion. I could cover up the one in the middle, and the two on either side are a proportion. All right, so how do I solve proportions? Yeah, the whole example the other day about solving proportions, and to do that, you cross multiply. The problem with this is I have two variables. I can't do that. Over here, I have two variables. Here, I have two variables, B and C. Okay, so what they want us to do is they want us to draw on prior knowledge, and they want us to realize that, hey, it's a right triangle. If I know 2 of the 3 sides of a right triangle, I can find the third. Well, in this larger one, I don't know 2 of the 3 sides. But if you look at the smaller one, you do. And at the top of the paper in class, I told you, write this formula, a squared plus b squared equals c squared, in where c squared, not c to the power of c squared, in where c is a hypotenuse, and a and b are legs. That's what they are. So what we went ahead and did is we said 17 squared, and I'm going to write this backwards, it doesn't matter. The hypotenuse squared is equal to 8 squared plus a squared. And this is going to help me find a, and I'll know all 3 sides in this triangle. And then b and c are actually really easy. So I'll do the work for you. 289 is equal to 64. 17 squared is 289. Plus 8 squared is 64 plus a squared. We got to get a squared by itself, so we got to subtract 64. When we do that, we get 225 is equal to a squared. What number times itself is 225? Well, we prove that by taking the square root of both sides. When you do that, the square root of a squared is a, the square root of 225 is 15. The last thing we want to do is ask ourselves, is 15 a reasonable answer? Well, the hypotenuse has to be the longest side in the triangle, okay? And it's always across from the largest angle. In this case, the largest angle is the 90-degree angle. It looks like it's the longer leg, so it's got to be more than 8, but it's got to be less than 15. Now, how do we find, so I come over here and I get 15. How do I find these other 2? Well, now, if I cover up this one, I have I have a proportion where I only have one unknown. But I don't want to work with 15 and 45. Those are big numbers. So what I'm going to do is I'm going to go ahead and I'm going to reduce. I'm just reducing. 15 goes into itself once, 15 goes into 45 3 times. All I did was reduce that ratio. Why? What does that do? Well, gee, I get 8 over b is equal to 1 over 3. Now if I cross multiply, b times 1 is b, 8 times 3 is 24, and I get b, the short leg is 24. Is that reasonable? Well, it's less than 45. All right. And then I go on and find, I can create the other ratio. 1 over 3 is equal to 17 over c. Again, I cross multiply. c is equal to 17 times 3, which is 51. And that hypotenuse is 51, reasonable answer. They want us to draw several triangles here. I'm going to draw a large one and a couple other ones. And I want to find points to cross nicely on my line here with my coordinate grid. So right here and here, I'm going to connect these lines, kind of like I'm translating. How far over did I go? I went 12 units. And how far up did I go? I went 3. But remember, it's rise over run. I ran first and then rose, which is fine. But I got to remember, it's rise over run. All right? And it wants me to create 3 triangles. Well, if I create 3 triangles, I'm going to have 3 ratios here. So the next one, I find 2 other spots along this line that cross nicely on my grid. One looks like right here, so I would have, again, ran a certain amount, and if you count that up, it's 8, and I would have rose a certain amount. If we count that, that's 2. And then there's one other triangle that I can look at here. I'm going to run, and I'm going to rise, and that is going to be 4 of a run and a rise of 1. And if we reduce all these, we get 1/4, we get 1/4. Now why does that happen? That happens because all of these triangles have a right angle right here, and they all share a common angle over here. They are similar triangles, that's why. Remember, similar figures, angles are the same, angles and sides. The last 2 things I'm going to look at are here before you do your work. Okay, giving you the same justice you would have gotten in class. I'm going to look at number 2. Why am I looking at number 2? I'm looking at number 2 because of this radical right here. And you're going, this is hard, I don't know how to do it. Fair enough. It's actually easy. Pay attention. Observe what your sides are. X is a leg, the square root of 27 is a leg, and 6 is the hypotenuse. Okay, so if I'm going to use a squared plus b squared equals c squared, just plug them where they go. Well, a, I'm going to say is my short leg, so I'll just call it x squared. ax, same thing. Plus the square root of 27 squared is equal to 6 squared. Well, gee, I got that, Mr. Wilson. 6 squared is 36. That's easy. Okay, 6 squared is 36. But think about this. Everybody knows that the square root of 4 is 2. But why? I can rewrite the square root of 4 as the square root of 2 times the square root of 2. That's equal to 2. It's the same thing. But why? Well, if I have 2 of the same number, that creates a perfect square. The square root of 27 squared is equal to the square root of 27 times the square root of 27. It's a perfect square. So anytime you square a radical, guess what you get? You get that number. So the square root of 27 squared is 27 plus x squared. I'm going to subtract 27. X squared is equal to 9. What number times itself is 9? 3. Is 3 reasonable? Yes, because 3 is less than 6. But wait a second. Is 3 less than the square root of 27? It has to be. Well, think about this. The square root of 25 is equal to 5, right? So the square root of 27 should be approximately, let's call it about 5.2. Something like that. We're just estimating. We can do that. And then finally down here at number 3, take what we learned in 2. Identify the parts. 3 and x, they're legs. The square root of 10, that's a hypotenuse. So the square root of 10 squared is going to be equal to 3 squared plus x squared, right? Legs, hypotenuse. The square root of 10 squared. Well, what did we talk about up here? Anytime you square a radical, it becomes itself. 3 squared is 9 plus x squared. Subtract 9, x squared is equal to 1. The square root of x squared is x. The square root of 1 is 1. So x is equal to 1. Is that reasonable? Well, it's less than 3. But wait a second. Is it less than the square root of 10? Well, the square root of 9 is equal to 3. So again, applying the philosophy we did up here, the square root of 10 should be, even if it's 3.1, It's more than 3. It's still the longest side. Your work is 1, 4, 5, and 6. Work on those. If you need a calculator for number 5, go ahead and do that. All right? There you go.